All right, let's go ahead and get into chapter 13.2. There we go. All right, in 13.2, areas of polygons and circles, we're going to talk about a few things also um, dealing with the areas at the end, how we deal with those. So one of the ways we can find area of a shape is what's known as a geoboard. Okay, the geoboard, these dots here, and you have a shape inside this geoboard. We can use what's known as the addition method. Okay, it says divide an area into smaller pieces and then add up all the areas. So as we look at that, let me get into my drawing. We can have this, each of these is a 1 by 1 square. So this would have an area of 1, 1, 1. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, and 17. Okay, there's 18 with those two added up. Here's and a half, and there's 19. So that should give me a grand total of 19, correct? Let's see what I got. Got all those. There's your 19 square units, okay? So that's a nice, easy way of doing some of that. All right, so here again, you have what's known as the rectangle method, which means you can put pieces together in rectangles. You still have these 1 by 1s. It says construct a rectangle, encompassing the entire figure, and then subtract the areas. So in this case, you have a 4 by 4, which means there's 16 total squares in the dots. If you add them all up, okay, and then you start subtracting the other pieces outside. Okay, so there's your 16 minus, and then the pieces that are inside here, you take these out, and you can get your 9 as you subtract them all. Taking ahead of halves and stuff, okay? Because what you got to look at is what you can take is if you take these two, that's an area of 2. When you take half, so this would be an area of 1. Okay, same thing here. Here's an area of 2, but since the line diagonal goes through, that's a half. So this is a 1. Okay, you can even do this. See here, this would be an area of 6. And since I cut this, I can take out a half of that. So this is going to be worth 3. And then the same thing here. This is going to be 1. And this is 1. That's 1, 2, 3, 4, 5, 6, 7. And so 7 away from 16 is 9. And so that's how you kind of go through all those. Okay, same thing with this one. You make out your piece and start taking out breakdowns. You can take out all these, okay, or you can start adding them up, okay, because the area of the hexagon equals the area of the surrounding rectangle minus the sum of the areas of all these pieces. And you get 4 squares left over, okay? So same idea. All right, so let's talk about area. So when you have area, you have what's known as square units, okay? Square meter, square kilometer, okay? That is where these little 2's come up. There you have your kilometer squared, hectometer squared, and so forth. Now remember, we add a square meter, a 1 by 1 meter is still going to be 1 meter squared. But now you're talking about a decameter, which is going to be a 10 by 10. So a square decameter is 100. So it's 10 by 10. Okay? All right. So here you have, so this is going to be 10 by 10, right? This is going to be 100 by 100. And this one would be a 1,000 by 1,000. And that's how those actually come up to get you your 1 million square meters. Okay, when it's a kilometer by kilometer, it's 1,000 meters by 1,000 meters. Same thing here. These would be a tenth times a tenth, a hundredth times a hundredth at the bottom, and then a thousandth over a thousandth. Okay, so in that same manner, we'd have 1 over 100 times 1 over 100, which would be a square centimeter. A centimeter is a hundredth of a meter. Okay? All right. All right, so how am I going to convert sheets of following? 5 centimeters, square centimeters, into millimeters. Well, that's going to be a tenth and a tenth, which would be a hundredth. So that needs to actually move over 2 decimal places. Okay, because from the way I figured it is this way. Okay, from centimeter down to millimeter, there is 1/10 of a difference. So if I take 1/10 twice, that's going to be 1/100 of a difference, which is going to move my decimal over 1, 2 places and get you your 500 millimeters squared. Now, I have 124 million meters squared. So remember, from meters, you have decameters, you have hectometers, and then you have your kilometers, right? Okay, and so that's going to be 1, 2, 3 places. Okay, times 2, that'll be 6 places. So you should end up with 6 places to the left, and I should end up with 120 kilometers squared. Okay, it's 3 places up, which means I moved the decimal. 3 places for linear, 6 places, another 3 places for area. Okay. All right. So far so good. Oops, gotta clear that out. Sorry. All right. So some English stuff. A square foot would be 12 inches a foot. So 12 by 12 inches would be 144 inches squared. Or 1/9 of a yard, or 1/3 of a yard. 1/3 times 1/3 is 1/9. 1 yard squared would be 3 feet by 3 feet, which is 9 feet squared. Or 36 times 36 inches, which is 1296 inches squared. And 1 mile, take how many feet in a mile, multiply it times itself, and you get the big numbers like you got there. Okay? Right? Then in land measurement, okay, in English we call them an acre. Okay? And then for an acre, and then you have square miles. Okay? In metric units, you have an aire. A-R-E is called aire. And then a hectare, okay, which would be like a square mile, but a square acre, an aire, and then you have a square kilometer. Okay, so some of the things they have, an aire is 100 meters squared. Okay, that's 100 meters by 100 meters. A hectare is 100 acres or aires, or 100 aires by 100 aires, which is a 10,000 meters squared. 100 meters by, yeah. A kilometer squared would be 100 hectares by itself. Okay, and then you have an acre, and I don't do a whole lot with these. You don't have to know a whole lot of these. You do need a term of an acre. Okay, square mile is 64 acres, or 640 acres, which would make it 80 by 80, right? So, which is a weird number, but that's just what it is. Okay. Some of these, I'm not going to have you do a whole lot of these. It does help know some of them, but I'm not going to make you convert too much of that. You can look at these. A square field, the side of 400 meters by 400 meters is going to be 160,000 square meters, which in terms ends up being 400 And to hectares, there's a 10,000 square meters in hectares, so that'd be 18 hectares. Okay. That same field in yards can be made in acres. So if it's a 400 yard by 400 yards, so 4 football fields by 4 football fields would be 160,000 square yards. And since for 1 square yard is 4,840, divide 1 acre into that many yards, which would give you approximately 33 acres. All right, here's formula stuff that you have to know. So area of a rectangle, you need to know it breaks up into length times width. Or if you take a rectangle and break it up into little units squared, tells you how many. So this 3 by 3 or 3 by 4 rectangle would be 12 square units. Okay. Parallelogram. Okay. Parallelogram takes the height of a parallelogram here and here. Here's your height. And it also takes the base. So this is your base. Base. So base times height. Okay, and the height has to be at a right angle. So we draw it inside the parallelogram. Okay, so the formula, base times height. All right. Area of a triangle, excuse me. Oh. Okay, so a couple ways you can do area of triangle. This is one way, 1/2 base times height. Now it's because it is half of a parallelogram. Here's your height, here's your base. Okay, you take half of the parallelograms, that's why it's 1/2 base times height. Some will write it base times height all divided by 2, and that's fine too. The biggest issue for most students, FYI teachers, is the fact that they'll forget to divide by 2. So they'll always double check that for them. Oops. All right. Then we have, so how do I figure out all these? How do I find the base and the height? Remember, the biggest issue is you've got to find a right angle. This is an easy one. 4 times 10 divided by 2. In this case, here you have a height. This is the only place they have. So they give you this. Here's your height. And your base, this extended would be the same here. So this ends up being the base. The 10 won't matter anything to the problem. Okay? And so you should have 8 times 5, 40 divided by 2. We're going height here. Oh, excuse me. I'm thinking I saw a triangle. That is my bad. Okay, this is a parallelogram that they're dealing with. I saw this. Height and 5, and that's going to give you this 40. Still, the 10 doesn't matter. Okay, sorry, whatever. All right, so then we talked about this one. This is your base. This is your height. Make sure you divide by 2. That should give you your 20, right? Now it's this one. This is what I had in my brain. I don't know why. So here I have a parallelogram of this triangle. I need a base and a height. This has to be my height. And this over here is my base. So 4 times 2 is 8 divided by 2. So this should be a 4. All right. So there's my 20 centimeters squared. Make sure we remember the units. And here's your 4 centimeters squared also. Don't forget about the units. Those are important. All right. So, whoops. Area of a kite is diagonal times diagonal divided by 2. So the diagonals of these guys inside. So diagonal times diagonal divided by 2. Area of a trapezoid. One base plus another base times h all divided by 2. You'll see this one a lot of times too. Height times base plus the other base all divided by 2 is a good one also. One I like. So 2 bases added up, multiply it times the h, and then divide that by 2. Works on all of them. Okay, all trapezoids. Now there are some special trapezoids. Okay, now this one, here's your base and your base. So that's 28 times 4, okay? And then divide by 2, and that's gets you 56. Now this one I do want to touch base on for a second is because here's things that you can find out. This is a 2 here. Now they do give you, now why do I know that's 2? Because of these lines, has to be 2, which means this has to be a 3 and this has to be a 3, okay? Now, how does that help me? Well, I still need to know the height in this problem. Okay, so how do I find the height? Well, this 2, that's 3, and this is 3. This is an isosceles triangle right here. This is also an isosceles triangle, which means if this is 3, this here has to be 45 also. That means the height has to be 3. So the height is 3, so that's going to be 10, that's 30, so that should be a grand total of 15. There's your 15. Okay, all right, so clear this so I get to the next page. All right, area of a regular polygon. Couple things about a regular polygon. Okay, first and foremost, it has to be regular for this to work, which means all the sides are the same. Okay, and what you're going to have is A times P. Now, what do these stand for? Okay, so P is the same as perimeter. Okay, A is what they call the apothem. I want to say I spelled that right. I hope I spelled that right. The apothem, okay, but it's called an apothem, okay? And the distance of an apothem is from the center of the figure at a right angle to the middle of the side, okay? So a couple things about that. It has to be perfectly in the middle. It's got to be at a right angle. The center to the vertex of it is called the radius of that. Now, how do I find that? You find the perimeter. So you add up all the sides. Remember, it's regular, so I can multiply by the number of sides, get my perimeter, and then times the apothem, the distance of the apothem, and all divided by 2. Okay? So the area of a circle, pi r squared. Okay, one you got. Here you have the apothem, but I don't care about the apothem, talk about the radius. Okay, so it's a radius squared times pi. And then the area of the sector, that's this shaded area here. Okay, we take the angle of that angle, that central angle, divide it by 360, and then multiply it times the area of the circle. In other words, we're taking a percentage of the circle and timesing it times its area. So it's if it's a fourth of the circle, or 90 degrees, then it's going to be fourth of the area, pi r squared. Okay, so it's the angle divided by 360, which is the whole thing, and times the area and the radius. And then last two things, okay, comparing similar figures. Okay, so when I have two similar triangles with a scale factor of k, the ratio of their areas is going to have a scale factor of k squared. Okay, same thing with the similar polygons. Okay, so to give you an idea how that's going to work, let's see here. What shape can I do here? Let's hold on a second. Okay, so okay. All right, sorry about that little issue there. So let's talk about, let's do a shape here. Good shape. Guess we'll do this one. All right, so if I have this shape here, and I have this shape here, okay, they are similar. Okay, we're going to say the two shapes are similar, which, let's say this is 5, and this is 8. Okay, And let's just say we're going to multiply by 3. We're going to give it a scale factor of 3. That'd be a 15 and a 24, right? All right. So that's a scale factor of 3. Now, I know the area of this rectangle is 40. Okay. So my scale factor of the area should be 3 squared, which is 9, which means the area of this should be 9 times 40, which should mean 360. Okay, well, what's 15 times 24? Okay, so 15 times 24, I'll take my trusty calculator. 15 times 24 is 360. Boom, got it. Okay, same thing with the areas of a triangle. If you know the area of a triangle, okay, then you take the area. If the scale factor, let's say, is 4, then the area scale factor is going to be 16, 4 squared. So if the area of this triangle is 3, okay, that would mean the area of the other triangle would be 3 times 16, which would be 48. And then you're done. Simple as that. Okay? All right. And that is the end of this session.